Okay, welcome, my dear friends. Very good evening. Today is our respected resource person, Dr. UGANDHAR sir, and young past participants, CPGET young aspirant. Welcome. So, sir is going to start about the important topic in taxonomy, that is numerical taxonomy. So, listen carefully, my dear friends.
So we are a
Please start, sir. Please start.
yes, sir. Then numerical taxonomy. So this numerical means the number of flowers, number of the sepals, petals, and number is major important role in plant taxonomy. That is called a numerical taxonomy. So this numerical taxonomy is a important for the number of the sepals, petals, and gain number of the petals means then 5 petals, 4 petals. Then also number is also constant. The numerical taxonomy, also known as a taxonometrics or a so phenotics. Phenotics is a method of a classifying organisms based on the quantitative analysis. Quantitative analysis means quantitative means quantity means that is also the shape or structure quantity of the analysis of a observable characteristics introduced by the Sokal and Smith. The snorkel and Smith in the 1950 is the first time to introduce the number, also called the quantity of the plants parts. So this approach is used the mathematical techniques to evaluate the overall similarities among the organisms. Similarities means one family member's number of the petals sepals are similar or equal to the all species of the organisms, all species of the plants in the same family, also different families in the one order, Renalius order, then also called uh, several order type based on the orders. Also, it is a one character, common character features. The numerical taxonomy, each organomy is scored for a large number of characters, traits, large number of them means that, and the data are analyzed statistically to generate clusters or groups, and one quality and one order or one family, the group of the species or group of the genera, which is also analytically similar type. This is a one character. Then refer to the phenotypic resemblance without necessary for considering the evolution relationship, unlike the cladistics. This is a one characters. Then it is based on the phenotypic characters or morphological, biochemical, physiological, etc. Morphological, bio means also got a chemical like structures. That is also important. Secondary metabolites, and also which has a major important role for a physiological function also. It can be uses of the quantitative methods to compare many characteristics, many characters, the number of the sepals, number of the petals, number of the ovules, and also called a stamens number uses. It can each character is typically given in equal weight. The weight is also called equal. Then the size of the petal is also equal to 5. sepals, 5 petals, equal size. The data are analyzed using computer to create the initial dendrograms or phenerograms showing a relationship. Dendrograms means phenero. Phenero means flowering. The flowering characters of the flower, color of the flower, shape of the flower, size of the flower are similarities in a single family or group of the plants in the same families. So this is also the steps of a numerical taxonomy. What are the means of the steps? How many steps are there? So these steps are selection to the operational taxonomic units, which are usually species or strains, species, the character selections, and also coding. The selection of the characteristic features are coding. Coding means a group of the families which can characteristic features of the similarities, that is called codes. Choosing traits and assigning numerical values, calculation of the similarity for distance, so coefficients using a formulas like a Jacquard dice. Jacquard dice scientists are proposed the calculation similarity of the distance of the and the coefficients. The clustering analysis, also grouping. So ODU is using also called algorithms like UPGMA are single linkage characters. It is a one. The construction of the dendrograms visual representation of the phonetic relationship. These are major steps for the complete description of the numerical taxonomy in the systematics of fourth APGA group structure. Then what are the major application of the numerical taxonomy in the plant systematics, which is also microbial taxonomy. Microbial means also microorganism relation to the plant species. That is also got a microbial, that plants and animal classification. Then biodiversity studies. The biodiversity studies it is also one drug and germplasm identification. It is a one characters to apply this type of numerical taxonomy important role in the angiospermic plants. This is also majorly four applications are majorly conformal to the microbial taxonomy, plant and the plant and animal classification, biodiversity studies, drug and germplasm identification. These four qualities are based on the numerical taxonomic level. What is a major definition of the numerical taxonomy is a classification system in a biological system that deals with a grouping of numerical methods. Grouping means one similarities of the plants, which are bunches of the plants in group. That numerical method is based on their characters of the state, characters, based on the characters to the say group. It aims to create a taxonomy using a numerical algorithms, such as a cluster analysis, rather than relying or subject to evaluation of their properties. Subject to evaluations. It is a one character. The numerical taxonomy is a method of a classifying organism with the help of numerical methods and countable methods. This method is a clarifying and illustrate the degree relationship among the organism in a unbased manner. Organism. So the organisms are arranged in the respective taxa based on their similarities and differences. Similarities of the number of numerical number of studies in a flowers. Then also dissimilarities also called a important role for the identification of the plant species in the numerical taxonomy level. So the main aim of numerical taxonomy is classifying organism using numerical algorithm. The period from 1957 to 1961 saw the development of first method theory of numerical taxonomy. So this period, 57 or 4 years between the 1957 to 1961 period, few scientists of the taxonomy to the reporting the numerical taxonomy level studies. So also called a Michael Addison and a French botanist planned to assign numerical values in the similar between the organism. Numerical planned also numerical values, the countable values or similarities in a group of the families, group of the genera, group of the order. So ladder, Robert and Sokal, Peter H.A. Also got a Smith in 1963, divided the field into the phenotypes, which classifications are based on the pattern of a overall similarities. All similarities are based to classify the plants into the groups by this 1963 scientist of field of taxonomist. And so similarities and characteristics in which classifications are based on the branching point. Branching means the branching means either side of the branches, monopodial branching, dipodial branching, that is also branch. Number of the leaves in either side of the stem or either side of the axis. A pair, you say trile, that is also one character. Then the the node consists of two leaves, or three, or four, that is also dithecous, monothecous, tetralobed anthers, that is flower, androecium or gynoecium. Androecium, you take the transverse sections, so bithecous, tetralobed, monothecous, bilobed. It is also one characters. The estimated the evolutionary history of the taxonomy. So this is the biology of a phenotypes Greek also got a phenotype to the appear is known as a taximetric studies. Taxi means the meaningful arrangements of the plants. Metrics means number base. In an attempt to classify organism based on overall similarities using area order, observation of the traits, observation of the regarding of their evolutionary relationships. Evolutionary relationships are based to the classification of the plants in the groups. This is also one aim or one, you see, principles of the numerical taxonomy in concern with the use of numerical methods for taxonomy classification. So this method was based on the two shared basic principles: overall similarities and equal weight. All similarities are equal, and modern phenotypics are sometimes are called the neo-Arsonians, neo-Arsians, and also got overall similarities. This two is also basic principles of the numerical taxonomy, which can in the 1963 outer taxonomic level, so which is also computerized phenotypic system. So the order of the computers allowed the numerical taxonomists to study large data sets and determine the similarities. Large data means large data of the character features of flowers, which are similarities based on the computerized phonetic system. What makes the phonetic robust? The greater the amount of information of a taxon, the greater the strength of the classification. Strength. Then every character gets equal weighting. Number of leaves in a plant. One plant to other plant. The number of the leaves is similar. The weight is also similar. That one character. Every character gets equal weighting. The classification is based on overall similarities. Overall, all means many characters, many flowering characters, vegetative characters to equal size, equal shape, equal number, that is numerical levels. The advantages, phonetic systems, which is also got a reproducible, the greater predictive values than other phonetic classification. Objectives and free and bias. Then integrate data from many sources. Integrate data from many sources can handle large amounts of data. Large amount of data. Data means, example, the characters of the flowers. Then also called the classification systems, which is important for the similarities. But disadvantages of the phonetic system that does not readily account for evolutionary change. Also called so vertical change of the organism, the convergent evolution, the two species are exposed to the same selection. So preserve the share similar features. We also preserve share same similar features. For example, cacti-like plants. Cacti. And anyways, that group of the plants are one character, catechin imposings. Then also cacti-like plants live in a deserts. These cacti belongs to the various families, includes the Asclepiadaceae, Euphorbiaceae, Asteraceae, and Cactus. Cacti. Cacti means it is a word, xerophytic type plant. The xerophytic nature. It is also one major characters. To the just few examples of these are included in the Asclepiadaceae, Euphorbiaceae, Asteraceae, and Cactaceae. In other words, not all species that look like are necessary members in the same group. All families, all group of the families are not same. Few of the plants are most relative based on the numerical qualities or quantitatively similarity, which are grouped into the plants. That is called the numerical taxonomical level studies. So which is also, these are morphological characters which are used. Then first leaf length, 0 less or equal to 9 centimeter, 1 less or equal to 18 centimeter. That plants, the total plants. Then second one, leaf width, 0 less or equal to 2 centimeter. That is the one qualities of the plants. And also got a petiole length. Petiole length is also 0 less or equal to the 0.5 centimeter. Then 1 less or equal to the 1 centimeter. Then also petiole morphology, 0 base swollen. It is also called a one pulvinate. Then petiole attachment, leaf shape, leaf symmetry, leaf base angles, leaf apex angles, leaf apex shape, leaf base shape, which are all is also called leaf lobation, leaf color, leaf odor, vein type, vein agritic, vein spacing, vein category, also maternity. These are all also 20 major characters in each one part of the leaf, that is called a morphology characters, which are used to the classification. Then few are a flower character. The flower is also one important rule of the families. It is also phonetic trees of the morphological data, phonetic trees. So this is also called a cladistics. What are the importance of the cladistics? Means the cladistics is a refer to the biological classification system that involve the categorization of organism based on the shared traits, which it is also one characters. Organisms are typically grouped. How close relative? which character based to the close related, based on the leaf, based on the leaf shape, leaf structure, venations, then also got a leaf margins, then leaf tips, leaf leaf borders, several any characters of the leaf and are vegetative or reproductive parts of the endoecium, gynoecium. It is also one type to the classification of the plants that is called a numerical taxonomy. The cladostics can be used to the trace ancestor back to the shared common ancestors and also evaluation of various characteristics. Evaluation of various types of the characteristics based to the classify the plants. That is, this process are involves the creating phylogenetics. Evolutionary using a morphological and a molecular orders. Means molecular means number of the chromosomes, number molecules means number of the first characters. DNA structure also got proteins and also got lipids and fats, carbohydrates. These are also molecules based on the number, the data value, visualization, evolutionary history, and the relationship between the species. One plant species, other plant species, both are called a relationship. These are called a, numerical taxonomical studies. Then what are the characteristics characters in the field of character? Specific termination is used to the describe character termed character states. And I means the specific means common character features. The type of the leaf simple. The type of the leaf compound. Also bifoliate leaf. Examples. So all the plants are trifoliate leaf, bifoliate leaf, tetrafoliate leaf. That is one common character features, common characteristic characters among the group of the organism or one family among the characteristic groups. Examples are plesiomorphology refers to the ancestral traits that a taxon retain throughout the evolution. Two or more taxa can share. So plesiomorphosis and resides in the different groups when it is occurs termed as a simpliciomorphism. Simpliciomorphize. This is also one characters which are a similarities of the two different groups of the families. When this occurs, the term is a simpliciomorphism. Apomorphy means refers to the derived state used to the definite specific clades, and a one group of the clades, two groups of the clades, that is the one characters. Then apomorphies can be further subdivided into the automorphic and also got a synapomorphies, automorphies. These are two types, which are also one group of the clades. The homoplasy refers to the character states that is shared to at least to two organisms, but is not found in the common ancestors of predecessor. Two organisms means one genera, other genera. These two organisms are which are found in the common ancestor or predecessor. Thus, the trait is aid to have evolved as a result of a convergence or a reversal. This is also convergent dependency, also got a divergent dependency. This is the one characters. Then aspects of the numerical taxonomy. The numerical taxonomy involves the following two aspects. First one, construction of the taxonomy group. Dissimilar and also discrimination of taxonomy. Two groups are there. The constructions means it can formation, origin, individual or selected, and their characters are spotted. Larger the number of characters, better is the approaches. So then the resemblance among the individuals are established on the basis of character analysis. Means individual selected planes. Examples are branching, also called placentation, and also called the phyllotaxy, which is a characters are spotted. A larger number of characters, better is approaches. Large number of the characters, more characters, which are similarities in one plant to the other plant. That two plants are which belongs to the same families. That is also based on the numerical taxonomic level. The plants are grouped into the species, into the genera, into the family. The discriminate of taxonomic groups when the taxonomic groups chosen for the study show overlapping of characteristics. So discriminated should be used in the select them. Discriminated means just differentiations. So not a dissimilarities in a two groups of lamps. The more characters are dissimilarity. More characters are similarities are based. Only two characters are dissimilarities to separation. Families are there. The more characters are dissimilarities or families are there, it can group into the families. The principles of numerical taxonomy, the greater the constant of information of taxa, and more the characters taken into the consideration of better classification. So it is the information that are more the characters are taken, more character features are taken to classify the brands. That is called a better classification of numerical level. The second one, every character should be given equal weightage in creating a taxa. And then branching, also phyllotaxy, then also symmetry, then also called sexual quality. That is called a weightage marks, weightage points based to classification. That is also second of principles. Then third principle is for comparison purpose, the similarities between any two entities of considered two entity characters are similarities. This is the one characters. Then third one, then correlation of character differ in a groups of organism under the study. Thus, distinctive taxa can be recognized. Then fifth one, phylogenetic conclusions can be drawn from the taxonomic structure of group from the character correlation. So, which is also important of the principles of a numerical taxonomical level. Also, the science of taxonomy is a viewed the practical as a empirical science, which are a phenotypic and so-called a cladistic features. The phenotypic similarities is a based on the classification, which is also the five major qualities are basis to classification of the plants. That is called a numerical taxonomical level. Then also what are the advantages of a numerical taxonomy? This data of a conventional taxonomy is improved by numerical taxonomy. It is utilized better and a more number of described characters. More number that the character which are more, it is also important. So unnumerical methods are more sensitive in a delighting taxa. The data obtained can be efficiency used in the construction of better keys and classification systems. The many existing biological concepts have been so retained in the light of numerical taxonomy. The numerical taxonomy allows more taxonomy work to be done by highly skilled workers. Highly, their weightage of the numerical characters are based to the classification of the plants. This is also more skilled workers based to classification of the plants based on the numerical level. The disadvantages of a numerical taxonomy. So the numerical methods are useful in a phonetic classification and not phylogenetic classification. That is important disadvantage. Only phonetic level, not phylogenetic. Not phylogenetic means the primitive and advanced type is not better. It is also one numerical taxonomy level. So the proponents of biological aspects, the concept may not accept the specific limits. It can found out these methods specific. So these characters are selection is the greater disadvantages these approaches. The greater disadvantages, it is not a sure to all of the plants are same qualities. So then different taxonometric procedures may yield different results. So this is also one major qualities of the new organisms or formations. But this is a important of the numerical level of structure or qualities or character in phylogenetic classification or APG. Fourth, then application of numerical taxonomy can be successfully used in the study of various groups of plants. These all qualities are based to separation of the plants in groups. This is also when can be used or successfully used in the study of various groups of the plants. Then with of numerical taxonomy, similarities and differences can be studies also. Similarity characters and dissimilarity characters are also studied in the numerical taxonomy. Then phytochemical data has been numerically analyzed to study the interspecific variations. Then the phytochemicals means that is also the secondary metabolites and also called the so latex, gums, resins, which is also phytochemical structures, also numerically analyzed to study the interspecific variations. It is the one qualities, but these are important of the qualities based on the organisms. Then major applications are this one.
Thank you very much.
So these principles are majorly the six major principles to the classification of the based on the numerical level means quantitatively, not qualitatively. This quantitatively means the weightage, the size, the shape, the number, then also called ranks. That that is also the first one is the greater than content of information of type one. Second one, every character should be given equal weightage. Every character means vegetative or reproductive or flowering. All is also same weightage to classify the plants. Then third one is for comparison purpose. The similarity between the two and the two entities of the considered entity families or entire families of the number. That is also third character. The fourth one is a correlation of the character different groups of organism under the studies. This is also thus distinct taxa can be recognized in the several group of the when you say so examples of the class and also called order, family, genera, species, which are also grades, also called the codes, also got the ranks of the systematic classification. This way it can base to the number of the species means one species have one qualities. That qualities are based on the numerical. లేకుంటే చేసి chemotaxonomical level, లేకుంటే cytotaxonomical level. Which one is also important? That is based to classifications. The phylogenetic conclusions can be drawn from the taxonomic structure of a group from character correlations, assuming some evolutionary mechanisms and also kind of pathways. This is also then so the science of the taxonomy is a reviewed and also practiced as a also empirical science. These are empirical science methods which are a basic also called a fundamental principles of the numerical taxonomic level. So this is also you know that the advantages, but the disadvantages. Then it is also major application of the taxonomy can be successfully used to the study to various groups of the plants. But it is also first with the help of numerical taxonomy, the similarities and dissimilarities are will be can be studied and also phytochemical data has been numerically analyzed to study the interspecific variations, which are all of the qualities are based to the classification that is called a phylogenetic or APG fourth group of classification. That is called a modern concept of angiosperm, also called the modern concept of the magnoliophyta means the systematic studies of the magnoliophyta. Only magnoliophytic plants or angiospermic plants are major important rule for the numerical taxonomic level, chemotaxonomic level, cytotaxonomic level, not then the gymnosperms, not the bryophyte, pteridophyte. Only angiosperms plants, major character features can be classified in the groups based on the numerical level. So this is the important of the studies of the numerical level of the classification. Sir, okay, sir, thank you very much. Okay, sir. Hello. So this is a complete of this. Today it is a very simple of the topic numerical taxonomy. It may be completed within the 40 minutes, not more than 40. It is a simple. So then
Thank you very much, sir. It is a good topic for the competitive exams, competitive aspirants, those who are going to attend CPGET 2025. So, my dear friends, if you have any doubts, please ask our respective resource person. Thank you, sir. Thank you very much.
thank you very much. Okay.